All right, periodic trends. So we're going to look at ionization energy and radius. So let's think about what those trends are. So for ionization energy, that's pulling off an electron, that increases as I go from left to right because we're getting closer to a full octet. They're going to want to give up that electron less. In the up-down direction, the further the electron is from the nucleus, the easier it is to pull off, so they'll be higher toward the top of the periodic table. So when I look at aluminum and indium, aluminum should have the higher ionization energy. That one, the electron will be closer to the nucleus. For chlorine and antimony, chlorine is higher up and it's further to the right, so for both reasons it should be higher. And then potassium and germanium, it would be the germanium because that one's further to the right. So that's how ionization energy would work. For radius, the larger atom of each pair. So radius increases as I go down the periodic table because we're just adding, further more and more bigger orbitals, but it decreases as I go to the right or increases as I go to the left, and that's because when we don't add orbitals but we just add electrons, they get attracted to the nucleus a little bit more. So now, tin or silicon, it should be tin because it's lower down. Bromine or gallium, it should be gallium because it's further to the left. Finally, I have tin or bismuth, so there's tin, and here's bismuth. Okay, so bismuth is further to the right, which should make it a little smaller, but it's lower, and that's a much bigger trend. When we add on an entire extra orbital, it's definitely going to get bigger. So, the left-right is opposite of the up-down trend in this one, but the up-down trend is much larger than the left-right. So bismuth would be the larger atom.